Today we are going to move on to the last section of Chapter 8. See, we are almost done with Algebra 2 this semester. And the topic is to solve radical equations. Okay, radical equations. What is one radical equation? And we know it has to be an equation, and then there will be one or more radical terms in that equation. That is the radical equation. See, so far, we have seen many kinds of equations. In Algebra 1, we have seen the linear equation. And then in Algebra 2, we have seen the quadratic equation in Chapter 6. In Chapter 7, we have seen the rational equation. Then we see another new type of equation. So that will be a typical equation like this. X plus 1, take the square root, equals 3. So this is a typical radical equation. First, we see the equal sign. It means this is one equation. And then we see some radical signs in the equation, a typical radical equation. And the purpose of the class today, we want to solve the radical equation. So there will be one unknown in the equation, like this x here. We want to know what x is to make the equation be true. Okay, so before we start to solve the radical equation, I want to remind you a couple of things. First one, okay, you should know, not all radical equations have solutions. It's very common that one radical equation does not have any solution at all. And another thing here, so sometimes, or we try to solve it, we always end up with some solution. Then we have to check if this solution we got the real solution or not. It's pretty similar to the rational equation. So to solve the rational equation, we know we have to guarantee that the denominator can never be 0. And same here. When we check the equation here, so first we need to check this radicand can never be less than 0. And the best way is always to substitute the solution we get back to the original equation, then check the left side or right side are equivalent or not. So this is very, very special about the radical equation. And to solve radical equation, what we will be doing, so we just apply one mathematical rule. It is called the square rule of the equality. So in one word here, that is, so whenever we have one equation, A equals B. So it's like a balance here. Okay, a balance seesaw. The left side, right side are equivalent. And when we have an equation like this, we can always square both sides of the equation. So when we have A squared when we have A equals B, then we square the left side and we square the right side. Those two must be equivalent as well. This is called the squaring property of the equality here, this equation here. So we can have this, all right? So having this in our mind here, now let's go back to the radical equation. See, to solve the radical equation, we want to get rid of the radical sign because we have learned how to solve the regular linear equation, quadratic equation, and how can we solve, because the x is inside of the radical symbol. Can we remove the radical symbol? And how can we remove the radical symbol? So now we are going to go back here. So think about this. So if I have one equality and we have like radical A equals whatever that is, maybe B or radical B, can be anything. Okay, so equals radical B, for example. This is one equation here. Apply the squaring property onto this equation. So when we have something equals another expression here, we can square the both sides. So we can just square the left side and then square the right side. They're still equivalent. See, when we square a radical symbol, what happens? They square and the radical sign, they cancel each other because they're opposite. Whatever inside the radical symbol, we call the radicand. That is, so we have A here, that's A here. So having this and to go back here, we'll have, so when we square A or raise a square, raise a power of 2 to a radical sign, we'll have the radicand. So A equals B. Having this in our mind here, we'll go back to our example 1. This is the easiest equation, radical equation. What do we have? We have one radical term equals a number. And what do we want? We want to get rid of the radical symbol. How can we do that? Let's square it. So I will square the left side. When I square the left, I should square the right side as well. I applied this squaring property onto that equation. I did follow the mathematical rule. Don't have to worry about anything. So see, after I square this radicand, the radical symbol here, what do I have? I will have whatever the radicand is, and it will be the new left side, equals what? Equals 3 squared equals 9. After I square the both sides of the equation, the radical symbol disappears. I have a brand new equation. What is new equation? That is what we have seen in Algebra 1. This is a typical linear equation. How can we get x? X equals 8. Okay, so for all radical equation, we should do what? We should do the check. So quickly check here, plug x equals 8 back to the original equation. We'll get 8 plus 1 squared. Does this equal to 3? The answer is yes. Radical 9 equals 3. 3 equals 3. That is the true statement. So now we can answer. The solution of this radical equation is x equals 3. So this is a very, very typical radical equation. What do we get from this equation? We get, if we want to get rid of the radical symbol, we just square it. But when we square it, we have to make sure this radical term is staying on one side by itself. So that equation here might show up in another way. So I get radical x plus 1 minus 3 equals 0. So sometimes the equation will be given in this way. And for that one, can I square the both sides now? The answer is no. Why? Because if we square the left side now, we'll square a binomial. Use the FOIL rule or apply the perfect square formula. After we expand it, we'll still have some radical sign inside. So we cannot square now. So this is what I want to share with you now to solve a radical equation. Step 1, we'll see how many radical terms are there. If there is only one radical term, so which means if there is only one radical symbol, we are going to isolate it. We are going to leave it on one side by itself. So before we start to apply the squaring property, we are going to leave or isolate this term, which means we have to move minus 3 to the other side. How? Just to move it, we change the sign. So negative 3 is moved to the right. It turns into positive 3. And this radical term is isolated. It stays on left side by itself. After we do this, now we are going to go ahead to apply the squaring property. We square the two sides and we can get rid of the symbol. So this is the first type. If there is only one radical symbol or one radical term in the equation. We are going to do this. And after we get the solution, we always check. Now, let me give you another example here. So sometimes, okay, or so see, I have one equation here. It is given like radical 1 minus x plus 1 equals x. See, what do we have here? We'll have one radical equation. We'll check, like I told you before. Step 1, we'll check how many radical terms are there. There is just one. So if there is only one radical term, we are going to leave it alone on one side. In other words, get rid of everything else with it. So I have one here, move it to the right. So this equation turns into radical 1 minus x equals x minus 1. So I just move the terms. And after I have this radical symbol staying on the left side by itself, what I can do now, I can go ahead, square the both sides. So when I square the left side, I will have the radicand only. So quickly do this in your mind. Square, square. So 1 minus x equals what? Don't forget, we have to square the right side as well. So square 8 and then square 8. Square the left side, we get the radicand. Square the right side, I get x minus 1 squared. Raise a square to a binomial. It equals square of the first term and then double their product, negative 1 times x, that's negative x double 8 minus 2x. And then plus square of the second term. 1 squared is still 1. And if you don't remember the formula, raise a square of a binomial, you can always rewrite it as a product. X minus 1 squared equals x minus 1 times another x minus 1. Then you can simply use the FOIL rule. Okay, you can still get the same answer. To save time, I do not go over this now. Go back here. What do we see? So after I square the two sides of the equation, what kind of equation do we get now? We see the square term. So when we say square term, remember what do we call it? Quadratic equation. And to solve a quadratic equation, what do we need to do? Recall what we did in chapter 6. We want to see 0 on the right side or on one side. So which means we are going to move all terms to one side. Because I have the square term on the right, see, I want to move everything to the right. So 1, negative x, they're all moved to the right. So I have x squared minus 2x plus 1 originally. When I move 1 to the right side, minus 1. When I move negative x, I get positive x. Then 0 is on the left now. Simplify the right side or combine like terms, I get x squared, so negative 2x plus x, we got a negative 1x. 1 plus minus 1, that's 0. So those two numbers cancel out, equals 0. Okay, or if you don't like this, now you can switch the two sides. X squared minus x equals 0. This is a typical quadratic equation. How do we solve a quadratic equation? When we say 0 on the right, we try to factor the left side. So then we got x times x minus 1 equals 0. When we have two factors, their product equals 0, that means either factor can be 0. So let's continue here. And we get, let's continue. All right, so I have x times x minus 1 equals 0. Then I let either x be 0 or x minus 1 equals 0. A review of chapter 6. To solve a quadratic equation, we do the factorization on the left. X equals 0, nothing need to be done. X minus 1 equals 0 to get x, x will be 1. So after we got here, we'll see that equation we are given here, we end up with two solutions. And what we are asked to do, remember, we are asked to check Okay, never forget to check the two solutions. The check means what? Plug the solution we get back to the original equation. Okay, so step one, I want to check x equals 0. Is x equals 0 a solution to the original equation? Plug x equals 0 back to the equation. I get square root of 1 minus 0 plus 1, that is equal to 0. So plug 0 back to the original equation. And we want to verify, are the two sides equivalent or not? Put a question mark here. We cannot tell now. We simplify the left side. So 1 minus 0 is 1. Square root of 1 is 1. So 1 plus 1, that's 2. And 2 equals 0? Apparently not. So that means x equals 0, and we call this is a false solution, not a real solution. It is not a solution. So that means we need to get rid of 0. Now we'll continue to check the second solution. Check x equals 1. Is x equals 1 the solution to the original equation? So plug x equals 1 back to the equation here. I got square root of 1 minus x is 1 now. And plus 1 equals 1. Is this true? Plug it back to the equation. Is this true? Simplify the left side. 1 minus 1, 0. Square root of 0, still 0. 0 plus 1, that's 1. So 1 equals 1. That is true. Now we can answer. Okay, so x equals 1. That is a real solution. So from this example here, I want to give you an impression. When we solve a radical equation, we have to isolate the radical term and then square it. When we square it, don't forget to square the other side as well. And we'll get either a linear equation or quadratic equation. Solve this brand new equation, we'll always end up with some solutions. But we cannot stop here. We have to plug the solution back to the original equation, the very, very beginning of the problem. What the original problem we are solving, plug it back, plug solutions back to the original equation. Then check, does the left side and the right side, are those two sides equivalent or not? If yes, then that's a real solution. If no, that's a false solution. This is the first type of the radical equation, when there is just one radical sign in the equation. So that means sometimes we might see an equation, there are two or maybe more than two radical symbols. For example, what we have here, we have this equation. Let me copy this down here. And if we have 2 square root of x plus 6. So this is example 3. When the radical equation here equals radical x squared plus 19. So this radical equation, there were two radical signs, and they happen to be on the two sides of the equation. See, we know that. So when there is only one, we isolate it and then we square it. There are two radical terms, and they happen to be on both sides. There are only two terms here. So I want to get rid of the first one. How can we get rid of the first one? I have to square it. So I square the left side, and then I square the right side as well, following the squaring property, this mathematical rule here. And after we square it, amazing things happen. What happens? See, when we square a product, so there's 2 times the radical symbol, each one gets the power. So there is a small, trick right here. Don't forget this 2 gets the power 2. So 2 squared, that's 4. And the radical x plus 6 squared will have the radicand, so 4 times x plus 6. that is the square of the left side, and equals square of the right side. The right side, this is a single radical term. When we square it, we'll have the radicand only, x squared plus 19. So this problem, see, when we have two radical terms and one on each side, when we square the both sides, both radical signs disappeared. And we have a brand new equation. For this new equation here, we have to get rid of all the parentheses. Applying the distributive law, 4 times x plus 24 equals x squared plus 19. What kind of equation do we have now? Square term, it is the quadratic equation. To solve a quadratic equation, we always move all terms to one side, either left side or right side. I prefer that the square term has a positive coefficient, so I move everything to the right. So that equals x squared plus 19 minus 4x minus 24. When I move a term, I change its sign. 0 is on the left. Then combine like terms, I get x squared minus 4x, 19 minus 24 minus 5, and equals 0. Then I just quickly switch the two sides. Equals 0. I rewrite because this is the familiar way, right? When we solve a quadratic equation, we prefer to write 0 on the right. So I quickly switch the two sides. How do we solve this quadratic equation? Factor the left side when I see 0 on the right. And this is a trinomial. The leading coefficient is 1. We'll need just two numbers. The two numbers, their product is -5. Their sum is -4. What are the two numbers? 1 and -5. So 1 times -5 is -5. 1 plus -5 is -4. Equals 0. Then we make each factor be 0. This equals 0, that one equals 0. We'll get x equals -1 or x equals 5. We have two solutions now. Then what we do, go back here, we have to check the solution here. So check x equals -1. Plug -1 to the original equation. This original equation does not have the square here. This is what happens, okay, in our mind. And now I plug this back here. I get 2 times -1 plus 6. That this equal to square root of -1 squared plus 19. It's really hard to see now. Then we simplify that equals 2 radical 5. This left side. What do we have on the right side? -1 squared, that's 1. 1 plus 19, that's radical 20. They do not look similar or identical for now, but we know we can always, so whenever we have radical expression, we have to make sure it is simplified. This radical 20 equals 4 times 5. 4 equals 2 squared. So these 2 can be moved out, which will be exactly 2 radical 5. Are those two same or not? So yes, that is. So -1 is a real solution. And in the same way, when we plug 5 into the equation here, we'll see x equals 5 is also a real solution. So that equation has two solutions, x equals -1 and x equals 5. This is the second type of the equation when we see two radical symbols. Okay, and we want to separate them. We make one on each side. So which means sometimes when we see the problem, so the problem might be given like this. So 2 radical x plus 6 minus radical x squared plus 19 equals 0. So when that equation is given like this, do not rush to square the two sides. We are going to move this term to the right. So there were two radical sums. Make them stay on both sides of the equation. So when we move this term to the right, it turns into positive. Then we'll get here. Now we squared both sides. And sometimes, okay, so sometimes we might see more complicated radical equation, but at this level, like for our final exam, you won't see a more complex problem than the example we see now. But just in case in the future for the higher level math class, if you see two radical terms, not there are not just two radical terms, there might be another term, or there might be three radical terms. What should we do? So in that case, you just focus on one radical term one by one. So I will just isolate one radical term, then move everything to the other side, square both sides. I will get rid of one radical term. And then you'll see there might be more terms left, then isolate another one. So do this, repeat the process. Every single term, every single step, you only try to remove one radical term. And eventually you can get rid of all radical signs. Then, but it might take some time. We won't see the problem that complicated at this level. Just be prepared in the future. Okay, you might see some problem. It has more radical symbols. The rule is we isolate one radical term, then square it. And when we square it, we square the other side as well. And then do this, repeat this process. Eventually, we can get rid of all radical symbols. Okay, so for the last section of chapter 8, so we have learned how to solve the radical equations. And you might see some problem. It is one radical equation, but there might be more than one letters. And those are called literal or letter radical equations, like this one. So what we are given? We are given one formula. You call this formula, but you know this is one radical equation. We see equal sign, we see the radical symbol. That is a typical radical equation. But because there are multiple letters here, there are multiple variables, we call this equation, okay, this is actually a physics problem because it's a formula. So given this, so treat this as just one typical radical equation. And we are asked, so given V equals square root of 2gr, where G represents the force of gravity, R represents the planet's radius, and me, does not matter. Okay, we just know there's G and R represent something here. And we are asked to do what? Solve for capital R. So this problem, I will rewrite, copy this problem down here is, so forget about all those words here. Simplify it, that is called, given this equation, V equals radical 2gr. There are three letters, and we are asked to solve for R. Whatever we are solving for, that is the unknown. So I will highlight it. So this is R is unknown. Then how about G, lowercase g and lowercase v? Does not matter. Treat them as numbers. They represent some number or numbers, we don't care. And we just leave them as the variable. And G, they are letters. And they can represent any number. What number, we don't care. So go back here. So to solve the unknown is staying inside of the radical symbol. What do we need to do? Get rid of the radical symbol. How can we get rid of it? Square the both sides. So given the original equation, I'm going to square the left side, and v squared, and then square the right side, 2gr, and then square it. When we square a radical symbol, we'll get the radicand of, so 2gr equals v squared. What do we have now? We have a typical, okay, and linear equation. Why linear? Because this unknown r does not have a power 2. And so this is some number, times r equals another number. How can we get r? So we just need to get rid of the 2g. Then r will be on the right side by itself. How can we get rid of it? Do the opposite operation. They are multiplying together. Then I will divide by the coefficient of r. Divide by the coefficient of r. 2g cancel out. I have r alone on the right. And what do we have on the left? V squared over 2g. Final answer. What is r? So for r equals v squared over 2g. Final answer. And this is, we call that literal radical equation. It's the same thing as we solve a regular radical equation. When there is just one radical sign, isolate it, square it, and then solve for the unknown. If there are two radical signs, okay, and then we are going to put them on the two sides, then square them, both of them, then both of them will disappear at the same time, and solve for whatever letter is solved for, that will be our unknown. All the other letters, just treat them as the regular number. That is called the literal radical equation. It's very similar to what we have done before. So after we remove the radical symbol, we'll have a linear equation, quadratic equation, maybe a rational equation, and just use what we learned before to solve that unknown. Okay, I think that's what I want to share with you today.